Hi folks, so today's November 1st, yesterday was Halloween, and Halloween for me is kind of a good news, bad news, good news, bad news, good news thing, and let me explain that. When I was a kid growing up on Long Island, we'd go out trick-or-treating, and every once in a while you come across a house where the owners would either be out or pretend not to be home so you didn't have to pass out any candy. And I swore when I grew up that I was not going to be one of those people. I was going to make sure I had candy for the kids, and good stuff too. And the good news is I have done that. Every year since I lived on my own, I made sure to buy Halloween candy. And not just because I didn't want my house to get egged. The bad news is we don't get a lot of trick-or-treaters here. In fact, yesterday we had none. And the bad news is that means I'm going to eat all the candy. But the good news is I always buy stuff I like because I know this is going to happen. Well, the weather's finally cooled down enough here so I can wear normal shirts with sleeves on them. And today I have on the bench yet another piece from Steve, but yet not a Sound Craftsman. This is a Pioneer SX-9000. And while I don't recall what the particular problem with this is, I hooked it up and it became apparent pretty quick where the trouble was. So I'm going to show you what it sounds like and then what it looks like on the scope, because I noticed in the past I have not done that. I've said, hey, we got distortion, but you wouldn't know what it sounds like. So I'm going to show you that. That's what the owner will hear, and if it's yours, that's what you'll hear. That'll get you to throw it up on the bench. So let's take a look at this thing. I'll show you what's going on. All right, this is a nice looking piece here, and I'm going to power it up. I don't have it on the dim bulb tester. This is a capacitively coupled amplifier, meaning it has big electrolytic capacitors in series with the output. I'll show you that on the schematic. And that means that it's not going to have any dangerous DC on the outputs because the capacitors are there specifically to block the DC coming out of the output stage. So I'm going to turn it on. And we're going to start some YouTube safe music. And I'll turn the volume up and you'll hear what we have. I'm only getting one channel also. Okay, got the volume halfway up. You can barely hear this. I'm going to put the microphone right by the speaker. As you can hear, we have massive distortion and only the left channel is working. So I printed a few schematics out, and I'm going to poke around in here and see what I find. And then I will show you what I found, how I found it. By the way, I never showed this part of it. I'm taking the bottom off now. And when I first started doing this work again about 14 years ago, I bought this Hitachi cordless screwdriver. I read about a review from some tool site, and they said it was a really good tool. And it sure was, because I used this thing so much I basically wore the damn thing out, and the switch is getting a little flaky. It still works, but I decided I was going to replace it. I think I paid like $68 for this 15 years ago. And Hitachi may have sold their tool line, because I replaced it with this Metabo, which is the identical tool. It was $10 cheaper. They come with two of these rechargeable batteries. They recharge about a half an hour. And this thing is just, like I said, I liked it so much I wore it out and bought another one. So this is one of those tools I highly recommend. I'm not an affiliate or anything. It's just something I found really works for me. Sometimes I tend not to use this when I'm putting the screws in because I don't want to cross thread anything. But it really makes short work when you have a whole lot of these. And it has a clutch on it, by the way. It makes it a lot quicker when you have something like this where you have a lot of tools to do, a lot of screws to take out. I remember taking the back off a Marshall 4x12 cabinet, and it had, I forget how many screws. So something like this is a good investment in my opinion. And I've shown this before, but I just want to show it again for anyone who hasn't seen it. I have a system. I take a large bag like this. They throw these out where I work. I go right back in the trash and pick them up. And I take a large bag and I mark what I'm working for on it. And then I have smaller bags. And this is where all the screws from the bottom are going to go. They all go into this bag. So if I have a bunch of things taken apart in one unit, I know what screws go where. The other thing I do, Steve still has the cover for this, but I took the bottom off and it's hard to see, but I wrote in pencil SX9000. So I have more than one thing taken apart at any given time. I order parts. It may be a week before I get back to it. I may or may not remember what goes to what. So it's not a bad idea. This is easily erasable and it's on the inside. Nobody's going to see it anyway. None of the voltages I measure in the power supply seem right. I even measured some of the AC going into a bridge rectifier and it was low. And when I look here on the back, this unit is set for 240 volts. And here in the US, that's not going to work. So let me set this to 120, see what that does for us. I'd never set one of these before, but I was unable to move the selector, so I took the fuse out, and sure enough, it's a type of plug. And you have several different choices on this. We have 240, 220, 130, 117, 110, and off. I'm not sure why you'd select off, but we're going to go for 117, which is as close as I can get to our US standard of 120 volts AC. All right, let me get a little signal in here so you can see what this looks like. You heard what it sounded like. As you can see, we only have the left channel. And this is what happens when we put some signal in. It is pretty ugly, that is. We're looking at what, 40% distortion and 0.00 watts. That's very low. As you could, if you recall, it was very hard to hear this. So we have a definite problem here. And I'll show you what I found. And we're going to try this again. Okay, so I've changed the voltage, and when you do this, you need to change the fuse. Generally speaking, your fuse should be twice the value at 120 volts that it would be at 240. So I've replaced the fuse, I've moved the selector to 117 volts, and now we're going to try this again. It's not going to fix our defective channel, I don't suspect, but it may do a lot for our distortion. So I'm going to turn it on and turn the generator on. And it looks pretty much the same, which I did not expect. But here we go. So I'm going to go back to troubleshooting. And just for the record, yeah, it still looks about the same. Honestly, I did not expect that. I didn't try it before I turned the camera on. So this is what you get. Okay, back to the drawing board. Be right back. Okay, so on the schematic here, I am looking at D1. You can see we have 78 volts and change. And this is the power supply schematic. D1 should have 90 volts. Now, initially, I only had about 30 some volts, and that's why made me look at the voltage selector to see if there was one on the back. And thankfully there was, because if it wasn't for that, it would probably have been a transformer problem. But that's pretty rare. So I see now that we only have 78 volts where we should have 90. So I'm going to take a look a little before this to see where we might have a problem. I think we might have some bad filtering, but I got to put the scope on it to be sure. Well, I've got the oscilloscope on there and the filtering is just fine. That's 1 volt per division, AC coupled, so we're only looking at the ripple component, and that is just fine. Don't worry about the jumping, that's normal with power supplies like this. What you want to look at is this. If the capacitor was bad, you'd see a lot higher of a display. So there's nothing wrong there. And when I look at the schematic on the computer, while this says that we should have 90 volts at D1, it says 82 volts with 70 volts in a circle, and that circle tells us that that's the voltage we should get at 60 watts output. We're under a no signal condition. So we should have, according to this, 82, we have 79. This is good. I don't know where the discrepancy came from though. I decided while I have the scope set up that I wanted to take a look at the input going into the output stage. This doesn't appear to have main in, pre-out, main in jumpers. So I wanted to check the input going in. And while I didn't see anything on the schematic that pointed it out, these shielded cables look like where the input is. So what I did was, and I'll show you on the scope, I connected to one side and turned the volume up. And as I turn the volume up and down, as you can see, we have signal. Looks a little non-linear at the bottom end, but I'm not going to worry about it. That jumping around is just sync from the scope. And you can see that signal looks just fine. And I'm going to check the other channel in, which if we look down here is just right here. And it's the same thing. We have good signal, plenty of gain. I can turn it up. So the problem is going to be somewhere here in our output stage. And I have to see if there's a way that I can lift this entire assembly out and get to the other side. More as it develops. One of the things I saw in the back of this unit when I was changing the power back to 117 volts were fuses for the outputs. And these fuses go right to the collector. They go to B1 and B2, I believe is what they show on the schematic. Anyway, one of them was blown, the one for the right channel. When I checked the output transistors and I checked them left to right, of course it's the last one, but I found an emitter to collector short. And let's see, I'm not sure you're going to be able to see the meter because of the glare in here, but we'll try. Okay, that looks pretty good. If I check from here to here, we look okay on this one. If I check from here to here, we have a dead short. So this is why our fuse was blown. We have a shorted output transistor, and we're going to have to check further back and see if there are other problems. If we look here at our output stage, we have two transistors here. These are our outputs, so we're going to have to check. I'm not sure which one is which. I'm going to have to see how they're laid out. We'll have to check this transistor. We'll have to check back this way. And as always, I've marked the schematic so I can trace the path of destruction and know that when I get back before it and everything's good, that we're pretty confident we found all the problems. All right, so I've gone through the one channel that's not working. I was able to get good signal through the working channel, and I'm not sure why, but I wanted to find out what happened because whenever I connect power up to the right channel, I put this on the dim bulb test and it was glowing fairly brightly, so I wanted to see what was up. This transistor was shorted, and I checked the bias pot. Now, the values on this schematic are all wrong. None of the transistor numbers match up. A lot of these resistors are not the same. And it shows here that we have a 50 ohm bias pot, and it's actually 500. Manual in the parts list listed at 50, but it's 500. But this is what it measures. So this is why we're having trouble with that one channel. It looks like the bias pot opened up. You probably can't see that, but I'm going to zoom in and maybe you'll be able to. But right on the back there, it says 500. and we're reading 25 meg. So this bias pot is, for all intents and purposes, open. I'm going to see if I have anything that'll physically fit that I can drop in there and see if that straightens everything out. I have a feeling it will. Okay, I have some 470 ohm. This one measures 439. It should be fine for this application. You're never going to see it go all the way to 500. So this is really just the bias adjustment. And I think this will probably straighten out the problem. So let me see if I can figure out how to shoehorn this in, and we'll see where that gets us. All right, I got that. Sorry, I don't have the mic on. So I have that bias pot kludged in, and I have it on the dim bulb tester, and it looks like it's working because I have the oscilloscope probe coming off the collector of the transistor that is not being fed directly by our power here. So that would be, this is where our B1's coming in this transistor, so we want to measure the collector of this transistor that we replaced. So I have the scope probe on there, and if you look at the scope, and I turn the volume up, we got good output on that channel. And then if I take the probe and move it from here, let's see where we can ground this. We're going to ground it right to here and come off of here. Brilliant. So I should extend this ground, but I'm not going to. They make them this short for high frequency work, which this does not qualify as. I mean, I'm feeding a 1 kilohertz signal in, and I could have extended that, but I'm lazy, I admit it. And here we have good output here, so I should be able to put this together. I think that's the only problems we have. Oh wait, I'm getting a spam call. Be right back. Now I have this reassembled, I've gone to check it out, and while the right channel is now working since I replaced that transistor, I still have problems with the left channel, but it checked okay when I was looking at just the collector of one of the outputs on each channel. So why does it look like this now? When I had to disassemble this, I have clip leads connecting everything on the board here, so I could do power on testing. What I discovered was, if I disconnect the output, so if I pull the lead out of the dummy load, we get this. We get a good signal. So what that tells us is that we have good voltage gain. Because remember, the oscilloscope measures voltage versus time. But we have not enough current gain to drive into an 8 ohm load. And that's why we're seeing what we're seeing. Well, after far too long a time, I finally realized that the other bias spot was also open, and I had a blown fuse on that channel as well. And it's kind of weird it worked at all, so I don't exactly know what to make of that. There are other power supplies that feed this board, so that may have been part of it. But now we have good signal on both channels. I haven't ramped it up much here, so let's see what we got. Alright, so we got around 40 watts a channel. I think that's about all this is good for. So I'll tell you what I'm going to do is feed in some YouTube safe music. Let's see what this thing sounds like now. Okay, well, I haven't reassembled this. I do feel confident that everything is now good. So I've got some music going in here. Okay, now I've got both channels and both sounding good. So we had one blown transistor, two open bias pots, two blown fuses. Kind of embarrassed I didn't pick up on that blown fuse earlier, but this is how it goes sometimes. I remember working on an old CRT based television and spent at least an hour tracing through trying to find a reset button that was on the front panel, recessed, and basically it's kind of like going through the tailpipe to get to the carburetor. Anyhow, this thing's good. I'm going to put it all back together. By the way, I always keep under my bench pieces of cardboard, different sizes, so I can do things like this. Take components out and put them on the bench and energize them so I can do power on testing. I also keep small pieces of wood, 1x2s, short pieces of 2x4, for the same reason, so I can chalk things up and keep them from shorting against the chassis while I'm checking them out. So anyway, this thing is now completely working. I got to check all the other functions, but I think we're good here. So I'm going to sign this video off right now. If anything else crops up, I'll make another short video to show what that is, but I think we're good here. So I'm going to go through, I'm going to recheck the bias after it warms up. I'm not sure what these may be balance pots. I'm going to go through that as well. But anyhow, that was the troubleshooting. Everything is now working. So as always, I thank everyone for watching, and I like giving back to the community that's given me so much. Thanks a lot, folks.